My study is identification of genetic variants associated with deep vein thrombosis (DVT) in a cohort of patients affected with DVT in Sri Lanka. Deep vein thrombosis is one of the known thromboembolic manifestations occurs due to genetic and non-genetic etiologies. Aim of this study was to design and implement an assay to identify genetic variants associated with DVT in a cohort of Sri Lankan patients. A comprehensive literature review was conducted to identify genetic variants associated with DVT. CYP4V2, RS1314672, and factor V, RS4524 variants were identified due to the cause of missense mutations to identify the likelihood of causing DVT. A novel tetra-amplification refractory mutation system, allele-specific polymerase chain reactions were designed, optimized, and Sanger validated to genotype the literature identified CYP4V2 and factor V variants. Total of 110 DVT patients were given prior consent for studies were participators in the study. DNA were extracted from all blood samples of those patients and genotyped using design and optimized protocols of this study. PCR products were visualized from across gel electrophoresis. There were 48 males and 62 females in this study population. For CYP4V2 variant, 14 were normal, 39 were heterozygous, 57 were homozygous. And for factor V variant, 37 were normal, 73 were heterozygous, and there were no homozygous. Determined allele frequencies at Hardy-Weinberg's equilibrium were 0.3045 for CYP4V2 variant's ancestral allele and 0.6955 for variant allele. And for factor V variant, it was 0.6651 for ancestral allele and 0.3349 for variant allele. On conclusion, the allele frequencies of both CYP4V2 and factor V variants were consistent with South Asian population allele frequencies, suggested the reliability of our findings. And this is a simple genotypic assay which can be used as an efficient, sensitive, and specific molecular diagnostic screening test for thrombophilic genetic variants in patients affected with DVT in Sri Lankan population. Thank you.